Welcome to Part 2 in Unit 13, Virtual Memory Techniques. We're going to do page replacement algorithms. So let's just take a look at this graph that the number of page faults, when you increase the number of frames, then you're going to decrease the number of page faults, but eventually you can give more frames and it's not going to really make a difference in the number of page faults. So let's do a page replacement algorithm here. This string 701203 represents page numbers. This process has around a minimum of 8 pages because it has page 0 up through page 7. And what this exercise we're doing right here, we are giving it 3 frames. So it has local page replacement and demand paging. So we're going to only load the page into a frame when it is demanded. So let's get started with the exercise. This algorithm is called FIFO page replacement. That means we're going to replace the first in, first out. So right away we have page 7, and any time that you have to replace a page, you have a page fault. And what we're going to be doing here is counting the number of page faults. So we have page 7 is in a frame, so we have 1 page fault. And now we load page 0 into a frame, and that's another page fault. So remember, since this is on demand paging, meaning the frames are empty, even when you first load a page into a frame, not even when you're selecting a victim, you will have a page fault. So we have 3 page faults right in the beginning. Now we need page 2, and we need to select a victim page to replace. We're going to use the first page that was loaded into the frame, so we're going to replace page 7. And that's what this is, first in, first out. Now we need page 0, so we're not going to, at this time we need page 0, so we're not going, it's already in a frame, so we're just going to reference page 0. Now we need page 3, so once again we're doing first in, first out, and we will replace page 0. Now we need page 0 again, so we're going to replace page 1. And now again, this is first in, first out. It's just a queue. You take the one that got in there first and you replace that one. And now we need page 4. So out of those pages that are in frames 2, 3, and 0, we're going to replace the first in, first out, which is page 2. And now, of course, we need page 2 again. So we're going to replace page 3. And now, of course, we need page 3. So we're going to replace page 0. And now we need page 0. So we will replace page 4. And now we need page 3, which is already there. Page 2 is already there. We need page 1, so we're going to replace page 2. And of course, this is an exercise, so we now need page 2. And we will replace page 3. 0 is already there. 1 is already there. We need page 7, so we will be replacing page 0. We need page 0, so we will replace page 1. And we need page 1, so we will replace page 2. So after this exercise is done, we have in our frames page 7, page 0, and page 1. And we can count how many times we had a page fault, so you just count them. And it turns out that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 page faults with this reference string with a first in, first out page replacement algorithm. So there's this phenomenon called Belady's anomaly, which says that when you increase the number of frames only in first in, first out, that you may actually end up increasing the page faults. So there's this dip in the graph that shows that when you increase the number of frames, instead of decreasing the number of page faults, you actually increase the number of page faults just for a brief time. Then it works again, and then it evens out. So this is the optimal page replacement algorithm. Now this has something in common with shortest job first scheduling in that you really don't know the page you're going to need the farthest in the future, but this will give you optimal results, so it's used for comparison. And when you go to select a victim, you look down your reference string and you select the victim of the page that you're going to be using the farthest in the future. And this will give you the minimum number of page faults. So again, we're still going to have our first 3 page faults because it's demand and there are no pages in any frames. And now we need page 2, so we have to look down our reference string and say, out of page 0, page 7, and page 1, which is the one we're going to be referencing the farthest in the future, and that's page 7. And page 0 is already there. And now we need page 3, so out of 2, 0, and 1, which one will we be referencing the farthest in the future? And so we're going to then replace page 1, because if you take a look at this location where we need page 3, we're going to reference page 0 again very shortly, and page 2 shortly, and page 1 is going to be the farthest in the future. And now we need page 0, and page 0 is already there. And now we need page 4, and out of 2, 0, and 3, which one will be referencing the farthest in the future? Page 0. And page 2 is already there, page 3 is already there, and now we need page 0, so we're going to have to replace, out of 2, 4, and 3, we're going to replace page 4 but we don't even see page 4 at all in the future. And now page 3 is there, page 2 is there, and now we need page 1. So again, page 3 we don't see anywhere in the future, so we'll replace that one. And 2 is there, 0 is there, 1 is there, and now we need page 7. So at this point, we're going to replace page 2 because that's the one we need the farthest in the future. And so you can look, and now 0 and 1 are there, and then you can count how many page faults. And with the first in, first out, we had 15, and with this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see that the optimal page replacement algorithm has given a much better result than the first in, first out. Moving on, we will get to the least recently used. And we will do the least recently used in the next video, and we will also do the second chance algorithm in the next video.